Hoy tenemos, y ahora mismo, una sesión bastante especial. Tenemos una persona mítica dentro de Microsoft que ha venido hoy para estar con nosotros en este día especial. Es una persona que actualmente es el vicepresidente de Cloud-2-Infraestructura, es la rama dentro de Azure dedicada a hacer soluciones específicas para determinados segmentos y verticales. Pero tiene una historia muy larga dentro de Microsoft. Tiene más de 19 años en Microsoft, en los que ha pasado por cargos tan importantes como, por ejemplo, el responsable de Azure Compute. Por ejemplo, tanto en la versión de Windows como en la versión de Linux. Si vemos los servicios de Azure, probablemente el más básico, el más fundamental es este. Él ha estado muchos años llevando ese equipo y dirigiéndolo como máximo responsable. Pero quizás lo más mítico de él, lo más curioso, es que aproximadamente hace 15 años él formó parte del equipo dentro de Microsoft que creó lo que por entonces se llamaba Windows Azure, que era el embrión de lo que hoy en día es Microsoft Azure. Es uno de las, como digo, de las personas míticas dentro de Microsoft que han empujado lo que hoy estamos viendo como nube y toda la expansión que ha tenido. Y el único tema es que va a ser intervención en inglés. Entonces os pido un pequeño esfuerzo, merece la pena, desde luego, y voy a cambiar ahora a inglés para presentarle. Así que, please join me in giving a very warm welcome to Corey Sanders.
Excellent. All right. Well, welcome everyone. It's great to be here this morning. I have about 30 minutes here to speak a little bit about infrastructure and talk to you all about some of the great advancements we've got in the platform. I want to start off just kind of level setting on what is, when we say infrastructure and sort of this baseline that is fueling all of the innovation and fueling all of the capabilities that you'll see throughout the day on data and AI, what is the infrastructure itself? And so the core components of this really are data centers and connectivity between them. There's the massive amount of data centers that we've deployed worldwide, more than 300 data centers worldwide, accounting for more than 60 regions, which is more than any other cloud provider in the world. To connect these is about 175,000 miles of fiber, so that is 280,000 kilometers. Just to sort of help explain this a little bit, if you were to take that and stretch it out, you could go around the planet 7 times. And so this is how much connectivity is required to make this entire environment work. And it allows many applications and solutions to be built, either exposed throughout the world or even deployed locally, but then made available to customers around the world. And so this capability is really massive and enables a lot of really exciting solutions. Now, when you think about this and you look at sort of what does one of these data centers look like, this is one location, right? So this is sort of just to give you a sense here, and you can see over here, these are cars over here, just to give you a sense of how big one of these is, right? And so these are the data centers that we've got deployed around the world. It just gives you a sense of how big this really is and how much computing power is required. And certainly with the age of AI, this is just increasing and getting larger, and the demands are getting more and more as we continue to see applications building using these capabilities. Now, the key for you, when you think about what this means, right? Why is it so important that we have this global scale? Well, there's a few things that make this really quite interesting, hopefully for you and for your solutions. First is offering this scale in a sustainable way. Being able to offer this while still reducing total energy usage, right? So as we continue to innovate and build on the data center side, how do we offer it such that it can take advantage of as little power as possible, and when it does use power, of course, it ends up using clean power. How do we enable it in such a way that it is highly reliable, right? As reliable as possible, both in the actual running of each one of the instances, but also in enabling your applications to take advantage of reliability features that make your applications even more reliable on top of that core infrastructure. Making sure it's trusted, it's secured, you have the ability to use a bunch of capabilities and solutions that allow you to secure your application in ways that are unique given the scale that we've got, right? The amount of signals that we're able to detect, what we're able to see, and then enable you to take advantage of as you're building security and protections into your solutions. And then, of course, leveraging all of this infrastructure for the innovation of the future, for this new AI wave, and how we think about AI applications being built on top of it. So first, just touching upon the sustainable transformation and what this actually means. So there's 4 big areas when you think of infrastructure specifically. There are 4 big areas of sustainability that we focus on. First is carbon negative, of course, and our focus to deliver that by 2030, and we'll actually, by 2050, remove all historical carbon since our founding in 1975. So obviously this is a big, bold goal and requires innovation in our data center design and our data center development to be able to deliver upon this promise. But this isn't the only promise that we have from a sustainability perspective. We also are promising to be water positive by 2030, zero waste by 2030, and protect more land than we use by 2030. And so when you think of the picture that I showed of the giant data center, obviously a lot of land is being used to be able to support this type of growth, this type of hyperscale. And so in ensuring that we are protecting land greater than what we're using is a key element of our overall sustainability. So all of these come together to deliver this infrastructure sustainability commitment such that when you're using our services and offerings, you have the ability to pass on these types of commitments and promises. And like I said, this requires a bunch of innovation. You can see all the way back to 1989, the sort of assessment here of our power usage effectiveness at the bottom. The goal here for power usage effectiveness, or PUE, is to hit 1. That means that there's zero waste of power. Every single megawatt of power then is used effectively. You can see back in early 1989, we were very far from 1, right? We were greater than 2, which means we had, in some cases, more waste than power that was actually used, which is certainly not a good goal. As you can see, a lot of innovation happens on our infrastructure side, and this is innovation that we do behind the scenes and simply pass along as part of our promise and commitment to you. And so this includes things like improving our density, improving containment, but it also recently has focused a lot on how we do cooling, how we enable cooling for minimal water usage and power consumption, because obviously as these get bigger and larger, the cooling components become quite critical to deliver the services with the right reliability. And so this has continued to innovate and advance over the years to some of the most recent advancements here where we have rapid deploy data centers to be able to deploy as quickly as possible, while also taking advantage of a new design that we called the Ballard design that allows us to place effectively 4 units of compute with overlapping power units between them so that we can make it as efficient as possible. And so this is the infrastructure innovation that, again, delivers on that sustainability. Now, the reliability side of the house is a really important one because in some ways it's a shared contract between us and between you. From a starting point, we drive very hard to deliver the highest amount of reliability on every single instance that's running in our environment. And so just to give you an example, this is sort of our a stat that we track very aggressively inside Microsoft, which is a single instance VM. What is the average uptime of a single VM running inside our environment? And so the average runtime is 99.99760, as you can see from the slide, which is, in some ways very good, but in other ways maybe not as good as it needs to be for your apps, right? So just to give you a sense, it's about 12 minutes of downtime in a year. which again doesn't seem that long, but if you say, gosh, I have 10 times, 1 minute downtimes, your app can be very impacted by that. And so this is where we really feel like it's a shared contract. We really emphasize the importance of you designing your apps, taking advantage of solutions that we offer. And so we will continue to work this number and ensure that we are giving the most resilient foundation possible. But we also are going to continue to build solutions on top so you can build apps and solutions that get even higher availability than that. And so this is where things like building across availability zones, so designing your application to be multiple instances and even multiple data centers. So as we continue to build regions, including regions built here, we will support multiple data centers for you to be able to span your workloads across them and get even higher reliability. We have services that enable this to go even higher, solutions like disaster recovery-based services to offer you to be able to span your workload multiple regions even. So within multiple miles away, somewhere else maybe in Europe, that you could then deploy the second instance of your application and enable failover. We also have backup solutions to be able to allow you to back up your data. And so these features are there for you to increase the availability and increase the uptime of the services and applications you're building. But of course, the top line is really for you. You need to design your app in such a way that it can use these capabilities to get the most from the platform, right? And that's both at an infrastructure level, but it's also at a platform level. So when we are building sort of platform as a service-based solutions on top and leveraging those, taking advantage of those high availability capabilities as well. And so the combination of all of this can deliver extremely high availability for you and for your applications and for your services, but it is that joint contract between us and you to be able to deliver on that. So moving forward into more of a focus on trust and security. A key component of infrastructure is being able to offer that high amount of trust and security. And certainly, a lot of the focus that we put in the building of our infrastructure is securing the environment on our side. Right? And so this ensures physical security, access controls, ensuring least access privilege principles to make sure that the environment is very, very secure from any sort of attacks that may occur. But again, there is also an element of your application building and taking advantage of services that we offer. And so one of the things that we've been really focusing a lot on is a solution that we call the Microsoft Cloud for Sovereignty. And what this does is it allows you to piece together components of our solution to deliver the right policy, the right governance, and the right controls that you need for your application, right? Whether you're working with a regulated industry, whether you're part of the government, or you're just following requirements and regulations for your application, the services here are quite valuable for you to consider. It starts with residency concerns, and certainly having a data center nearby certainly helps to deliver upon that promise of residency, making sure data doesn't leave, making sure data remains within either Spain or, of course, the EU, to be able to ensure that you're living up to those expectations on personal data or any type of data that needs to remain resident. But then above that, we have controls in place for you to manage and configure policy. Who has access to what? What are the expectations around access controls? Is it just in time? Do you only want to give access when needed, but keep things locked down for the rest of the time? What encryptions do you want to use in what services? All of these can be controlled in policy that then allows you to configure your environment to make sure it is secure always. And you can audit access, you can ensure that people who are changing things have the right controls to do it. And so this gives you the confidence and the trust in the environment built upon the trust that we put in when we build the infrastructure. Now, one key feature and capability that we offer as part of this trust is what we call confidential compute. And confidential compute is an infrastructure-based capability that allows you to deliver upon data in use level encryption. So this is actually really cool. By default, across almost all of our services, we offer data at rest encryption and data in transit encryption. So this means any connectivity, any data that's moving between machines, any data that's being stored in storage, let's say, these are all encrypted in those stable locations. One of the hardest things to do, though, is in use, while the actual processor is using the data, actually executing against the data, and ensuring that encryption applies there as well. And this is where confidential compute comes in. This allows you to protect and encrypt the data even while it's in use inside the CPUs and inside the RAM of the actual infrastructure. And so what does that mean when I say you can encrypt it using a key that you have that we don't have, right? And so this gives you protection against quite a few things. It gives you protection against any insider threats, either on your side or on our side. Ensures that we don't have access to the data when it's encrypted in use here. And neither do insiders on your side, right? So it allows you to protect it from that type of threat, from that type of attack. Any hackers, let's say, potentially at risk running on the same machine as yours, if you have anxiety about that, this will encrypt from other processes running inside that machine as well. And then, of course, any sort of third-party attacks as well. And so this is just a great way to offer that incremental level of control that you may want to have for your data running in the infrastructure. And we do have services that are built on top of this as well to enable those types of confidential services sitting right on top. And so this is a key component of the overall Microsoft Cloud for Sovereignty, where you have, of course, our baseline of trust. You have the policy controls that you can implement. You have all of the compliances that we live up to and audits that we follow. And then, of course, confidential compute sitting on top of that for you to offer that extra level of encryption even while in use. Excellent. So all of this is driving key innovation. And enabling key innovation. When you think about the scale that we're talking about, this is really when the future and actually current state of AI has been incredibly dependent upon scale. And that's why when you think about hyperscale and these giant data centers, the ability to deliver upon that scale is a key component for enabling that future. And so the key parts of this AI transformation really consist of three big areas. One is to amplify human ingenuity, right? So enabling people to have a co-pilot and enabling them to deliver solutions. And I'll talk about a couple co-pilot examples later. Delivering transformational experience by building intelligent apps, right? And so these apps are going to leverage key components of our AI platform, but they're also going to leverage core components of our infrastructure platform. And so putting these components together, enabling these applications to be put together will be a key aspect to building these solutions. And then, of course, safeguarding your data, right? And that's sort of the focus on trust and the focus on enabling those solutions, those operational resiliencies, and, of course, those security features. And so just to give you a sense of what we're talking about when we talk about scale. This here is the #1 supercomputer for cloud that we talked a little bit about a year ago, 561 petaflops of computation. And so just to give you a sense of when we say infrastructure scale, so this is obviously a giant infrastructure deployment, a giant infrastructure environment that we launched. When we think about the scale over the last year, we've launched this many into our public cloud. And so the growth of what we're seeing, all driven by AI, all driven by the demands of AI, is pushing a massive amount of infrastructure throughout the world. 30x of those supercomputers deployed around the world. To be able to deliver upon this growth and this need. So this is the core of the infrastructure, delivering upon all the promises and all the exciting solutions on the AI front. And so what are the capabilities that are enabled in this AI innovation? And so it spans across many different aspects of the Microsoft Cloud. First of all, unlocking productivity. And so enabling with Microsoft Copilot, you can unlock productivity in all aspects of your platform, right? And so obviously we spend a lot of time talking about M365 Copilot and enabling productivity across your information focus and communication, things like Teams. But there's also productivity gains to be had in your infrastructure management. And so the Copilot built into Azure allows you to do exciting things from an AI ops perspective. So how can you enable better improvement, better operational controls using AI, right? Enabling your Copilot on Azure to be able to drive questions or answer problems that you may have in your infrastructure. And so the Copilot effort, it spans many different areas. Security is another key one that's worth looking at for being able to drive improvements in your overall security infrastructure and your security focus. And so across each one of these different aspects of the Microsoft Cloud, these Copilots will help drive productivity, will help drive improvement in your overall operations. It also offers you to build AI solutions, right? And so you'll hear a lot in some of the other sessions about how to build AI solutions, leveraging this full stack, including things like the Azure machine learning capabilities and Azure OpenAI. Now, these are all leveraging and building on top of the core infrastructure. And so capabilities like fine-tuning or training your own models would all leverage that same infrastructure with all of the same scale that I've talked about, and those will feed into these AI applications and solutions. And of course, again, focusing on trust, focusing on safeguarding your business, safeguarding your data, and making sure you're leveraging the right security solutions to be able to deliver upon that promise of infrastructure. So let me give you a little bit of a sense of some of the usage cases of what this looks like and what this could mean for you based on the scenarios or solutions you're looking to build and how those layer on top of our infrastructure. In financial services, an example that we've seen pretty regularly is around risk and fraud detection. Being able to take AI, being able to take this massive infrastructure, being able to run risk assessment using that infrastructure and using AI, and leveraging that as part of a back-end data store. Right? And so this is a very exciting opportunity to be able to take advantage of this massive scale, of this being able to scale in and out very quickly and build a nice fraud detection solution for banking and for other financial services. Health and life sciences, the big one here for leveraging this type of scale infrastructure, of course, would be genomics and some aspects of precision medicine. So being able to get to faster drug development or being able to understand how drugs can be tested in the safest way does require a significant amount of infrastructure and AI-based capabilities. And so being able to take advantage of the infrastructure to being able to scale quickly, again, using this confidence and trust and security enables these types of healthcare-based solutions. In things like media, you can take advantage of this with personalization, right? Being able to use AI to be able to drive the right personalization, the right customer-focused engagement models, sales-based solutions that will take advantage of the requirements that you have specifically for your customers. Including retail, you also have sort of next best action and sales-focused solutions that can be built. And of course, with energy, the opportunity to be able to do grid, deep sea understanding, being able to take advantage of this for HPC-based solutions, take advantage of the infrastructure for that type of analysis. So let me give just maybe a little bit more detail on the first one and show you a little bit of an architecture of what this could look like. So we do actually have a set of banks in Canada that are leveraging a risk-based solution like this one. And so they've built this solution with a focus on sort of these three tiers of application. And it really brings together everything that I've talked about thus far. First, of course, the infrastructure at the bottom, making sure that the infrastructure can enable massive amounts of high-performance storage to be able to take all of this data in one place, be able to connect and secure the networking. And then what they've done with confidential compute is they've created an environment where multiple banks can share data in a confidential way without exposing data they don't want to share. And so this is the benefit of what they've done with confidential compute, is they've created this sharing environment that allows them to take advantage of the infrastructure across multiple banks, because for risk fraud detection, the ability to share signals is quite valuable, but they certainly don't want to reveal anything as part of that sharing, and so that opportunity with confidential compute allows them to create this environment for that type of sharing, for that type of privacy control that they need. And so that's the base infrastructure. When you go a step up and you look at the AI operations, they manage their solutions using AI ops, and so they manage using AI capabilities, infrastructure as code, policy controls, as I've mentioned, to be able to secure who can access what. All of that, again, managed and configured using the Azure environment, using AI to be able to improve those operations and try and automate as much as possible in the solution. And then, of course, from a services perspective, they use Microsoft Fabric for their analytics. So when they finally get all of the data out and they're running against this huge amount of data they've got stored, they'll use Fabric to be able to run their analytics. And they actually are using AI Studio to build AI solutions on top of those analytics. And so all of this comes together to give an outcome that they're trying to drive, which is understanding their risk and understanding fraud as they're helping their customers to deliver the right financial services in country. And of course, all of this made possible by the data centers that are deployed in country. And so it all begins and sort of ends with that core infrastructure, that exciting ability to have resident data centers to be able to deploy to and leverage, with all the solutions built on top and deliver this final solution. And so each one of those industry examples I gave has a picture like this, and each one can deliver those outcomes for you and for your customers. And so I'm excited about what we're all doing here today. I'm excited about some of the announcements we're making today, and I look forward to seeing the amazing applications that all of you build, highly resilient, using trust and security features that we've got, and enabling those capabilities for your end customers. And so with that, thank you very much, and enjoy the rest of the show.